And when do you have your next test or quiz in math?
He never said it, so
Okay.
yeah. November. Okay, let me share my screen. You see it?
Yes. Yeah, I see it.
Okay, there it is.
Geometry honors. Okay, so everything but 4, 5, 6.
Yes.
Okay, 1, 2, 3. Geometry. Okay, IP congruency proofs. Directions. Write a 2-column proof. Given RV is perpendicular to UT, S is the midpoint of VT. Prove the triangles are congruent. VRS, VRS, and TUS. Okay. All right, so you're given that RV, the vertical RV and the TU are perpendicular, are parallel, sorry, parallel.
Yeah.
S is the midpoint of VT. S is the midpoint. Okay, yeah, S is the midpoint of VT. Prove that they're congruent. Okay. All right,
Right.
so use the first piece of information. RV and UT are parallel. So if they're parallel, what does that mean?
They're equal to each other.
Not equal, but okay, so
There
parallel.
are two straight lines that are
They
not
never,
touching.
yeah, they never touch, right?
Right.
They never touch. Okay, so that means that if they're parallel, we know that a few things are. Can you zoom it? Can you blow it up?
Yeah, yeah. And for these, he wants us to put a statement and to prove it as well.
Okay, statement and write a 2-column proof. Okay, so we know that I'm drawing arrows on these lines. So this and this are parallel, right? So
Right.
if those two parallel lines are parallel, they never touch. But what else? What do we know in terms of angles? What do you know? What do you notice? What do you know about this angle? What do you know about this angle? What do you know about this angle? And what do you know about this angle?
Well, you know that the parallel lines are RV and TU.
Yep. Yep. Okay. What else?
Um, they're are they congruent or?
Well, that's what we're trying to prove, right? That's what we're trying to prove.
Yeah.
Okay, so since these two lines are parallel, these two vertical lines are parallel, this angle has to be this angle.
Right.
And then this angle has to be this angle.
Right. That would be the vertical lines theorem thing, right?
Do you have the vertical line theorem written in your notes or online?
Yes.
And then the last thing is this right here. This angle.
So, I'm gonna go get my notes real quick.
Okay.
Okay, I got it.
Okay, so there's a few ways that your teacher should have taught you about congruent triangles. Side angle side is one of them. What's the other ones that they went over with you?
Other way he taught me what?
Like, see how this says prove this one is congruent to this one?
Yeah.
One way is side angle side. Did they teach you to you like that?
Yeah.
Okay, so what are the other twos? What are the other twos?
AAS and ASS.
Angle side, and what was the last one?
Was it
Side angle side? I think angle.
angle SA?
ASA.
ASA.
ASA. Okay. So we got to prove one of these for for the two triangles to be congruent, okay? All right, so since these two lines are parallel, these two vertical lines, this is equal to this is equal to this, and this is equal to the opposite one because of opposite angles. So which one of those three is that?
Equal to S?
Yeah, this right here is equal to that because of opposite angles, right?
Right.
Okay, so let's start writing it. Okay, so we can say it says two column proof, right? Two column. All right, so we'll write something like this. Since RV line segment RV is parallel to UT.
Oh, he has like a certain way he wants us to
Okay,
write.
yeah. Tell me how you write it. Well, we're essentially write this.
Let me. I think he posted it.
All
Let
right.
me look. You don't have to erase anything.
Okay. Well, basically, we're saying those two lines are parallel, so those angles all match up. So
Right.
that'll be angle side angle.
Okay, so yeah, it's right here. This is how he has it written.
Okay, statement and then reason on the right. Statement and reason. Okay. Statement and reason. Okay, so for the statement column, we'll write something like this. All right, go back to the other one. All right, so this one will be statement column, statement, and then reason on the right. Statement.
Right. So for the statement, he said to write what the question is, and then for the reason, just put given, and then the second one is when you really start the.
Okay. Okay, so first one, since those two lines are parallel, since that's given, right? That's given.
Yeah.
Then we know that angle, this one here is equal to this one here. So we'll say angle, what is that? UTS, angle UTS is equal to which one?
UTS. So it would be
RVS, right?
Yeah, RVS.
RVS, angle RVS. And what's the reason there though?
I don't know about the reason.
The reason is
It's like these, I think it's like some mathematical.
it's what they call Z pattern. Like I learned it as Z pattern, but you guys learned it as alternate
Alternate interior angles theorem.
okay, yeah, there you go. Alternate angles theorem.
Yeah, alternate interior angles.
Okay, sorry, alternate interior angles theorem. Alternate interior angles theorem. Okay, so that's theorem. Okay, so that's number one and two. Number one, number two, and number three. What's number three?
It would be the I forgot the name of it. The little ticks around the S.
The little, oh, this angle right here? And this one?
Yeah, but it would be in a semicircle.
Oh, like this. You mean like that, right?
Yeah.
Yeah, those angles. Yeah, those two angles are equal to each other. Okay, so we're gonna say angle TSU equals angle what?
RSV.
TSU equals VSR.
Okay.
Okay, so here's the thing. See how this is written? We're trying to prove that these two triangles are congruent, right? We're trying to prove this right here, right?
Right.
So see the way it's written, VRS? that means V corresponds to T, R corresponds to U, and S corresponds to S.
Right.
We'll write it in that same order. So TSU, first, third, second, equals first, third, second, VSR. There's your VSR. So it has to be in that same order. Okay, so now what's the reason here? Opposite angles. What do you guys call it? You guys call it something different, right? What do you guys call it? I just call it opposite angle. What do you guys call it?
I think it's he has it in the notes.
Opposite angles.
Yeah.
Okay, yeah. What's the all right, let me erase this. What does he call okay, see how on C there he has midpoint is given. That one's congruent to that one. Definition of midpoint. Angle BCA, vertical angles are congruent. Oh yeah, he says vertical angles.
Okay.
BCA, BCA, and ECD. Yeah, vertical angles are, yeah, okay, vertical angles.
Right.
That's the reason, vertical angles. Oh, so not opposite, but vertical. This one's vertical angles. Vertical angles. Vertical angles. Okay, that's number 3. All right, number 4 is what? Okay, so now we're going to use this right here, the midpoint. So S is the midpoint of VT. So what does that mean?
The midpoint of VT.
Yeah, S is the midpoint of VT. So what that means is, where is V? Okay, so that means that this and this are the same length.
Right.
Right, midpoint definition. So we're gonna say VS is the same as VS is the same as TS. Definition of midpoint. Definition of midpoint.
Okay.
Definition of midpoint. Okay, so what do we have there? Which case do we have there? We have angle. Okay, so which one did we say first? We said UTS.
We had the angle, the same side verticals, and the midpoint.
And we have this D, right? So which one of the 3 is that?
Oh,
Angle, side, angle. What's the other 2? Angle, side.
What was it? SSS. Wait, no. Yeah, there is SSS.
Side, side.
SAS.
SAS, side, angle, side. Okay.
AA. No, yeah, you got that. And there's one more, but it's just for right angles only.
Okay.
So that'll just be HL, but that one you don't need to put.
Okay, so we got our 2-column proof. Which one of these cases is that? Angle, side, angle. It should be angle, side, angle.
Yeah, it should be.
Yes,
it's angle, side, angle. Yeah.
Yeah. So therefore, the last one will say 5. Triangle VRS is congruent to triangle TUS because of SAS, side angle, side angle. Sorry, ASA.
And then 5 would be S. Yeah.
VRS is what they wrote here. Triangle VRS congruent to triangle TUS because of ASA, angle, side angle.
Wouldn't it be SAS?
SAS. Okay, show me we know that this right here and this are the same length because midpoint. Where's this side here coming from?
The S would be on the T, right? The tick. Isn't that a side?
This and this are parallel. That doesn't mean they're the same length.
Oh, okay.
right? Parallel lines don't necessarily need to be the same length,
Right.
but the midpoint, that means they're the same length.
Okay. Right. Oh, and you also wants me to draw
Okay,
it.
so that one, AS, and SSS. Okay, so that's number one.
Yeah, he also wants me to illustrate it, so I'm drawing it real quick.
Okay, and does he give the answers for this? Oh yeah, he did give the answer for this, right?
No, he doesn't give the answer for this one, but he gives the answer to another one that's similar.
Okay.
Yeah. And vertical angles as well.
Yeah, number three is vertical angle. Or
Okay.
opposite.
So that's number one.
Yep. Or copy that down or take a picture of that.
Yeah, I just did.
All right. All right, I'm gonna erase it. We'll go to two.
Okay.
Two. All right, what is two? Okay, given MR is parallel to PN. Okay, where's MR? MR is this, so this is perpendicular to this. MR is congruent to PN. MR, okay, and so, okay, so that means it's the same length. Okay, so they're parallel and they're the same length.
Uh, what about right angles?
Okay, so do we have any right angles here?
Right.
Where would the right angle be and why?
Would it be on the bottom right of that?
Right here? Why?
Because it's perpendicular.
How do we know it's perpendicular?
Because it has the L shape.
This L right here?
Yeah.
It does have the L shape, but we don't necessarily know that it's perpendicular. Okay, so look, if we have two vertical lines, that line and that line are the vertical line, or I meant parallel lines. Those two are parallel. Then if we draw a line here, that has to be perpendicular.
Right.
Let me think about that. If we have two parallel lines, that means this is 92. If we have two parallel lines and we draw a line on the base, okay, given they're parallel. All right, let's try this. Okay, so, all right, number one, let's see what we got here. Number one, okay, what is it? Statement. And what was the other one? The other one was reason.
Yeah.
Reason over here. Okay, so first we're gonna say, okay, use the parallel line. So we're gonna say MR, line segment MR is parallel to PN, line segment PN. That's given. So since those two parallel, what do we know about the angles?
They're congruent.
Angles can't be congruent, right? Triangles can be congruent, but angles can be equal to each other.
Okay.
Okay, so let me see here. This one. Okay, so in terms of angles, that means that, where's our Z? Our Z pattern means is this one is the same as this one. And this one is the same as this one.
So for this one, I'm looking at my notes and I found like a similar shape. On those, he wants us to do like the half circle, but on opposite vertical angles.
Half circle.
Like alternate interior angles. So the half circle,
Oh, you have one just like this?
yeah.
All right, let's see. Let's see it.
Let me see. Like this.
Yeah, that one there. Okay, so that, yeah, this one's circular. Okay, so he says, okay, so first, number one, they're parallel and they're, oh no, this one a little bit different. MN is parallel to PQ, MN, okay, so the top is perpendicular to the bottom and the left is parallel to the right, okay. Prove that they're congruent, MQN, oh yeah, this is similar. Okay, so we're gonna copy that first statement. The two are parallel and, oh, that's given. Number two, he says MNQ, yeah, this is Z-pattern right here. MNQ is congruent to angle PQN, and MQN. MQN is MQN. Yeah, it's the same thing. So what's his reason? If parallel lines, alternate interior angles are congruent. Okay, so number one and number two are the same thing as what we're going to write for number two. Okay, so for this one here, it's okay, statement. MR is parallel to PN, that's given. That's number one. That's number one.
Yeah.
Number two, we're gonna say that the other part that's given. MR line segment NR is congruent to what is that? PN. So that means there's the same length. The first one means they're parallel. The second one means they're the same length. So this is given. Given. Number three. Okay, now we're going to start talking about angles. Okay, so now, just like
he wants us to include number one and two together.
Okay, just combine this as, okay, just combine
MRPN, comma.
Okay, just combine those two as number one. This is number two.
Yeah.
All right. All right, so number two, we're going to say now we're going to say angle, we're going to say angle MNR. So angle MNR is congruent to which angle? Angle M first, third, second, MNR, PRN.
So wouldn't it be PNR?
What did I say? MNR and PRN.
Okay.
Angle PRN. And he said the reason would be alternate interior angles are equal because of the parallel. What do you say? If the lines are parallel, alternate interior angles are congruent. Alternate angles are congruent because parallel lines. Because parallel lines.
Okay.
Okay, so basically 1 and 2 are the same thing. We're going to copy 1 and 2, just change the letters.
All right.
Number 3, he says QN is, okay, yeah. So when you see that for number 3 there, all that means is QN is common to both. So for what is this, number 3? Number 3, we're going to say this line right here, NR equal line segment, I meant. Line segment NR equals line segment MR. And the reason was, what did he say? He didn't say common. What did he say there? He said
reflexive.
Yeah, reflexive. So this one will be reflexive property. Reflexive property. That just means they're common to both.
Right.
Okay, so what else do we have? Okay, so what do we have here? Which one do we have there? Do we have any of those 3 yet?
Yes.
Angle, side angle, right? Yep. Angle,
yeah.
Side angle. Yep, there you go. So number 4, we'll say that triangle MRN congruent to triangle PNR because of angle, side angle, ASA.
Correct. Okay.
That one good?
Oh wait, let me see if we're not. Let me see. Okay. So number 3.
Number 3. All right, so see that vertical line in the middle? That's going to be common to both.
Okay.
All right, let's see what we got. This one's probably going to be angle side. We'll see.
Okay.
Okay, so here we go. Okay, number one. Okay, so given FD bisects angle CDE. Okay, so that means that this angle here is the same as this angle here. What else did you say? Angle C is congruent to angle E. Okay, so that this is the same as this. Angle C is congruent to, okay, prove CFD is congruent to EFD. Okay, number one. Okay, so this is going to be which one? Which one of the proofs is this going to be?
You would first write the given.
Okay, so FD bisect.
You don't have to write it. You just have to write number two because it's just repeating itself.
Okay, all right. So for number one here, we'll say just FD bisects blah blah blah, right?
Yeah.
Okay, so FD bisects angle CDE.
And also and then the reason would be given.
Yeah, exactly. Yeah, this one will be given. All right, so okay, it's given though, but what does it mean that if FD bisects angle CDE? What does that mean?
That they're both equal, right?
Yeah, both of these angles here are equal. It bisects it evenly on both sides.
All right, so that would be this. That one would be just the semicircle, but not the two line semicircle.
Semicircle, but not. Okay, yeah, I see what you're saying. Let me draw it for you. I think I know what you're saying.
Yeah.
You're saying that this one equals this one, right?
Yeah.
Yeah. Okay. Yeah, that's right. All right. So okay, FD bisects angle CDE. Given. Number two is what?
Would it be
This? Or you say you're writing it as one, right? This number two, you could say angle C equal or congruent to angle E. That's also given.
Oh, okay.
That's also given.
Oh yeah, I wrote that as one.
Okay, so this is really angle. Here's your. We need to start writing it like this. That's angle. That's another angle. And then for number three, we'll say that DF, line segment DF equals a line segment DF.
Right.
So there's your, and then this is what, reflexive, right? Reflexive.
Yeah, reflexive property.
So there's your AAS. Reflexive, AAS. So the next one, number four would be, therefore, the two triangles are congruent. Triangle CFD is congruent to triangle EFD. EFD by AAS.
Right. And AAS.
Yeah, angle side.
Okay. All right.
All right, we got skip 4, right? Skip 4, 5, 6.
Yeah. To 7. Oh, I've never seen this one to classify.
Okay.
Okay.
All right, 7. Find the value of the variables and any requested measures. Okay. Okay, classify triangle RVU. RVU. Okay. This one.
I haven't seen this one in class before, so
Okay. Once you see a couple of them, you'll understand it.
okay.
Okay, so look at the triangle on the left.
Right,
It
with
has
the
a
right angle.
yeah, right angle. This one's right angle.
Okay.
Right angle triangle. Right angle triangle. Number B, classify angle triangle RUS. RUS. What's this angle right here?
Alternate interior.
Oh, no, just tell me the measure.
Oh, would it be 64 and no 68 minus 40?
180 minus 68 minus 46. What is that?
Wait.
This is what, 104 or 114?
Yeah.
That's 114. So what's left over from 180?
66.
66. Okay, so here's 66. So what kind of triangle is that? This one.
I'm not sure.
Acute.
Cute. Oh, so how do we write this now? The classify stuff.
Did he give you any examples like that or no?
No, I have no. Wait, let me see.
In the notes?
I've never seen anything.
Oh, right. Hold on. Go up one. What's this one right here? Corresponding parts of no. Go down.
Well, that's all the notes he gave.
Okay. All right. That one's just acute because all the angles are less than 90. So this one.
Wait. So he said reminder that IP lesson due Thursday. So I had class today on this stuff like the ASS. So I think what he I'm not sure if the
IP.
homework.
What's IP? What does that mean?
Oh, the IP is the homework.
Oh, okay.
So I'm not sure if he means it's due in class on Thursday because he's gonna go over this,
Okay.
or if he means it's due that tonight, like that night.
Oh, okay. Well, we were gonna have it done anyways.
Okay, let me see what he means by like how to do this. It might be an older thing. Yeah, let me check what you did for last week on that.
Or weren't you on a holiday last week?
I mean the week before last week. Sorry.
Okay. Oh yeah, right.
No, just it's the same.
All the way. Go all the way down just to make sure.
Okay. Oh yeah, let me go back.
I mean, there's only a certain amount of triangles, right? Isosceles, right?
Yeah.
Okay, it doesn't look like it.
And let me see. Isosceles. It might be this one.
All right.
I think it might be this one. No.
It's similar. It's similar. It's not exactly, but it's similar.
Yeah. Okay, so let's still try though.
All right. Okay, so well, since RUS is the triangle in the middle, that one's acute because all the angles are less than 90 degrees. And then he's saying classified triangle UST. UST. Okay, so since these lines are parallel, this has to be 66. And then how much is left over from one?
I'm gonna grab a napkin real quick. I'll be back.
All right. 80 minus 66 minus 38. This is 76.
Okay.
Okay, so RVU we said was a right angle triangle. RUS is an acute triangle. I forgot the triangle. Acute triangle. classify triangle UST. UST is also acute.
Oh, should I write
Oh
classify?
no, sorry, my bad, my bad. This one's isosceles.
Okay. Should I write classify on my paper?
No, just put which one it is. This one is isosceles.
Okay.
I forget how to spell it. Isosceles triangle. Right angle triangle, acute triangle, isosceles triangle.
Okay.
Because
So-
of these two lines on the side here. This and this mean the same line.
So I don't think I was in class for that part. So can you tell me what's the difference between acute, right, and like isosceles in them?
Yes, no problem, no problem. Okay, so this one, right angle, means it contains one 90-degree angle.
Right.
Contains 190-degree angle.
Right.
Acute means all three angles are less than 90 each, are less than 90 degrees each, 90 degrees each.
Yeah.
So like 60, well, 60, 60, 60 is a bad example. 60, 60, 60 is equilateral. Acute is like kind of like this one right here, 46 plus 68. And then what would you say this one was? We said that one was
66.
66. So see how all of the three of them are less than 90? That's an acute. So 46 plus 68 plus 66. So all three angles are less than 90 degrees each. Isosceles means two equal angles.
Oh.
So isosceles, this one's 38 also.
Okay.
Because of those two lines there, that means the two base angles are the same.
All right. And what was the top angle for that one?
Okay, 38 times 2 is what, 76? So 180
Yeah.
minus 76, 180 minus 76 is 104. This is 104.
Okay.
104 and 76 is 180.
All right. That makes sense.
All right, that's what, 7? Okay, 8 equilateral triangle ABC has a perimeter of 117 units. If BC is 2x plus 11, find the value of x and measure angle A. Okay, no problem. All right, so what do you know about an equilateral triangle?
Equilateral?
Yeah, what does that mean?
Are they equal to each other?
All three lengths are equal to each other. Yep.
Okay.
All right, so let me, you got 7?
Yeah, I got 7.
All right, I'm gonna erase this, what I wrote. All right, so equilateral triangle just means, okay, so isosceles means two, oh, okay. Isosceles means two things, I forgot one thing. Two angles are the same and two lengths are the same.
So what's the difference between angle and a length?
Okay, I'll show you. The angle's on the inside, the length is the length.
Oh, okay. Oh, so the length is like the perimeter?
Yeah, exactly.
And okay.
Exactly. So look, just to keep things simple, right? There's a length, there's a length, there's a length, right?
Right.
On the inside, that's an angle, and that.
Well, the angle is just that curvature in the middle, technically.
It's basically the measure between two lengths.
Okay.
Measure
Right.
between two lengths. Measure between two lengths.
Right.
Okay, so now equilateral triangle, which one is that, 8? All right, let me draw our equilateral triangle. Okay, so this is number 8, right? Equilateral triangle. That length, same as that length, same as that length. That, and that are the same length. Now, equilateral triangle means another thing. This angle is 60, this angle is 60, this angle is 60. Okay, so what does it say? Equilateral triangle ABC has, okay, so this is A, this is B, this is C.
So for equilateral, right?
Yep.
Even the angles are equal to each other?
Yes. Yep.
And so the length and angles are equal to each
Yes. 3 equal lengths, 3 equal angles.
other? Okay.
And the measure of the angles is 60, 60, 60.
All right.
So that's what equilateral triangle is. Okay. So equilateral triangle ABC perimeter. Okay, so perimeter equals 117, right?
Right.
If BC, okay, so where's BC? BC is right here, 2x plus 11. Find the value of, okay. What do you know, what do you notice about, what is this length?
Which length?
BA.
BA.
This length, AC.
The length AC.
Yeah, what are the two other lengths?
What? 60, right?
Those are the angles. This is 60. I mean, that's 60 on the inside.
Okay.
60, 60. I'm talking lengths though. I'm talking lengths on the outside.
I'm not sure.
This is 2x plus 11. Right? They're all the same, right? 2x plus 11 here.
Oh, yeah. Yeah.
2x plus 11 here. Okay, so how many 2x's plus 11s do we have?
3.
So 3 times 2x plus 11 equals what?
So
117.
Oh yeah, right.
I'll just expand it out. What do we have? We have 6x plus 33 equals 117.
And that is the perimeter too. So it gave you it. So that proves it's right.
Yeah, we're almost there. We're almost finding x, right? Find x is one of the questions.
Right.
Okay, so now what is this? 6x equals what? 6x equals 117 minus 33 is what? 84? Yes, 84.
83.
83. Can't be 83.
Oh yeah, 84. My fault.
Okay, now 84 divided by 6 is what? 14. So x is 14. X is 14 degrees. No, not 14 degrees, just 14. Okay, so there's your x.
And it wants us to find the measure of A.
Yes, angle. Oh yeah, so measure of angle A would equal what? 60 degrees.
60.
Because it's equilateral.
Right.
The reason would be by definition of equilateral triangle. Definition.
We have to write the reason.
Well, I don't know if he said he doesn't say write the reason. I just telling you just so you know.
Oh, okay.
Definition of equilateral triangle. Because some of those other questions he said the reason, but this one he didn't say the reason.
Oh, and also I have this little thing that he gave us.
Oh, sorry, I wrote 11 there. I meant 14. I think I meant 14. What is that?
It's just this little like cheat sheet that he gave.
Okay. Do you have equilateral triangle on there?
Huh?
Does he have equilateral triangle on there?
Equilateral? No.
Maybe in the notes in the portal, if you see equilateral triangle, 3 equal lengths and 3 equal sides. Sorry, 3 equal lengths, 3 equal angles.
Oh, he never put out notes for this.
All right, so that was what, 8? So the answer is 14 for x and 60 for A. This is 14 and this is 60 degrees here.
Okay.
This is units, right? Units.
Let me write degrees.
14 units. 14 units and 16 degrees.
Right. Okay. Number 9 now. Wait, how much? Okay. 9.
Number 9.
The legs of an isosceles triangle have lengths of 5x plus 2 and 8x minus 16 units. If the base measures 15x plus 4 units, find the triangle's perimeter.
Okay, let's draw a diagram.
Okay.
Okay, the legs of an okay, so here's your isosceles triangle.
So the base would have to be equal, right?
No, the base is the different. This length is the different. This length and that length are the same.
Right.
The base measures 15. This is your 15x plus 4. And the legs of an isosceles triangle have lengths of, or legs of that and that units. If the base measures that units, find the triangle's perimeter. Okay, so let me see. This is 5x plus 2. And this is 8x minus 16. But these should be the same length. The 5x plus 2 and the 8x minus 16 should be the same length since it's isosceles. The legs of an isosceles triangle. The legs of an isosceles triangle have lengths of that and that units. If the base measures that many units, find them. So just add them together.
8 and 5, right?
8 and 5. Well, all three of them. The 5x.
Oh, all three of them?
Yeah, the 5x. Right. Perimeter. Remember, perimeter is just adding up all the outside lengths.
Okay.
So what is?
So it'd be 28x.
Yep, 28x plus what? Minus 10.
Minus 10.
There you go.
Yeah.
There's your perimeter.
So it is just that's it? That's the perimeter?
Remember, how do you find perimeter of a triangle? If that's 3, that's 2, that's 1. How do you find the perimeter?
You just add all of them?
Same thing. Same thing with the algebra.
Okay, so that's the answer?
That's it.
Oh. That was the easiest one so far.
That one's pretty straightforward. Find the triangle's perimeter. Just add up all the lengths.
Yeah. Okay, so number 10 involves 2 triangles. Oh, I remember he had something for this.
What is that? T right there? Given. Okay, so what? Okay, it's 2 of them. I got you. Okay, A is that, or no, ABC is that, and SRT is that.
Yeah.
Given triangle ABC is congruent to RST, find the value of X. Okay. Find the value of Y, find the value of Z. Okay, no problem. Okay, so see how this is written?
Yeah.
A corresponds to R, B corresponds to S, and C corresponds to T. So right in that same order, A and R is the same thing. So if we redraw ABC, how can we redraw ABC? So it looks like this one. A would be R, which would be this one here. B would be what? B would be S, which would be this one right here. And then C would be this one right here. Okay, so now just relabel it. AC is 23. There's your 23. This is A. What do we have? Angle B is 57 degrees. B is 57 degrees. And CB is 20. There's 20 meters.
Okay, so how are you finding this again?
Okay, see this right here? See this, what he wrote right here?
What?
See what he wrote in the box right there? Given triangle ABC is congruent to RST.
Oh, so we have to write reason and statement, or?
No.
Okay.
I'm just writing it in the same order.
Okay.
So like I said, A corresponds to R, B corresponds to S, and C corresponds to T. So I just rewrote the first triangle in the same orientation as the second triangle.
So you're just combining both triangles technically?
I'm just sort of, just making them in the same shape, and then so we can read it easier.
Okay.
All right, now we're going to answer the questions. All right, value of X. Okay, so where's X here? Okay, so look, since the 2 triangles are congruent, for this one, we're going to say X minus 6 equals 20. So what is X there? X equals what? X equals 26, right? Meters. So look, this one, that equals this. X minus 6 equals 20. X minus 6 equals 20. So that means X is 26. Get it?
Okay.
That's why I redrew this triangle on the bottom.
All right.
All right, value of Y. So look, this one here equals 23. Y plus 8 equals 23. Y plus 8 equals 23. So that means Y is 15 meters. Get it?
So Y plus 3 equals. Oh, yes, I do get it.
This one here, Y plus 8 equals this one right here.
Yeah, that makes sense.
Okay. And then the last one, value of Z. Okay, so look, We have that this is 57. We have that this is 51. So what does Z have to be? Z has to be 180 minus 57 minus 51 degrees. What is that? That's what, 108? What's that, 72? 72 degrees.
So Z equals 72 degrees.
Yep. Because remember, the two triangles are congruent. They give us the 57, they give us the 51. So the only other angle has to be 180 minus 57 minus 51.
Right. That one was a little tricky.
That one was, the main thing is just redrawing this first triangle and then matching up the sides and the angles.
Yeah.
All right, that was what, 10?
Okay. All right, this one looks straightforward.
All right, that one. That one's similar to one of the ones we did earlier. All right, for number, okay, value is X, value of Y, value of Z. Did they state anything above?
No.
No, okay. Value of X, okay, value of X, value of Y, value of Z.
So these are just angles, they're not lengths.
Well, look, this one will be an angle, X will be an angle, Y would be an angle, Z would be an angle. Yep, there will be angles, yep, not
Right.
length. Okay, so how are we gonna do this? All right, so look at, let's look at the X first. Okay, so we know, let's just look at the triangle on the right first. We know that 60 plus 39 plus 2x plus 11 equals 180, right?
Right.
Now just simplify. What's 60 and 39? That's what, 99?
Yeah.
90, okay, what's 99 plus 11? 110?
110, yeah.
So 2x plus 110 equals 180. So 2x equals 180 minus 110, which is 70. Therefore, x is 35 degrees. There's your x. Okay. All I did was add up the three angles that they have to give you 180.
Right.
And then simplified. 11, and that is 50. Yeah, okay. Okay, y. Same thing for y. Okay, look. Since x is,
wouldn't just saying wouldn't Z be 60?
Z be 60. No. How do you know that?
Because they're both opposite interior.
They could be they are opposite interiors, but that doesn't mean they're equal.
Okay.
Okay, so since x is 35, how much is this angle right here? How much
is that this side?
How much is this? No, the angle right here. How much is this whole angle right here?
2x plus 11, right?
And x is 35. So 2 times 35 is 70 plus 11 is 81.
Right, so that whole angle would be 81.
There you go. There's your 81. Okay, so what do you notice about those angles combined?
Both of those combined?
Yeah.
What
do you notice about y minus 3 plus 81? How much does that have to give you?
Would it just be y minus 78?
Y minus 78? Oh, I see what you're saying there. Well, this will be y plus 78 the next one, right? But what's this answer?
Yeah.
What's this answer right here though? When you add this one and this one, how much do you have to get? Straight line.
Well, I'm not sure.
180.
Oh, okay.
Remember, this angle right here plus
Yeah,
this angle right here has to equal 180, right?
Yeah, I forgot about that principle.
Yep, straight line. Now just simplify. Y plus 78 equals 180. So therefore, y equals 180 minus 78, which is what, 102? 102, there's your answer.
Right, so y plus 78 would equal 180.
80, yep. And then subtract 78 from both sides.
Right.
Okay, so look, if y is 102, what's 102 minus 3?
102 minus 3?
Yeah, 99.
99.
So this one's 99. This one's 53. How much is z? Z,
Is it just both of them combined?
subtract that from 180, yep.
Yeah.
180 minus 99 minus 53, how much is that?
180 minus 99. 28.
There's your z.
Okay. Oh.
180 minus 99 minus 53. Yep, 28. Yep.
Yep.
Good.
Number 12.
Oh,
Oh, that's a weird shape.
okay, same idea. All right, for that one. Okay, find the value of x at y and z. Okay. All right, for this one. Okay, so how are we gonna do this one? What is this right here? What is that right there?
Oh, arrow.
Where would the other arrow be though?
So that angle would just be x plus 7.
Oh, I see. Oh, I got you.
Yeah.
Okay. All right, so let's see here. Okay, so what do you notice about this angle and this angle? What can you tell me about those angles?
They're corresponding.
So what does that mean?
They should be equal to each other.
Exactly. What do you know? Okay, so let's do that. Oh, actually, this one's z plus 7. Okay, let's come back to that one. Let's start over here. Okay, we have an isosceles triangle, right? There's a tick and there's a tick. So we know that this equals this. 2x plus 10 equals.
And also the other side, both of those angles equal to each other as well.
Oh yeah, right. Yeah, exactly. All right, where do we start then? Okay, let's start with this small one. Let's start with right here. So we know that this angle right here has to equal what? X plus 17? This one here, right?
Yes.
Yeah, because of the two ticks here, right? Okay,
Right.
so for that one, we're gonna say, let's start with the X. Two of those, 2x plus 17s plus 104 equals what? When you add up the three angles of a triangle, how much?
17. I'm writing it down, sorry.
180.
So that give, yeah, I was about to say.
So two of these, right? Two of those ones plus the 104 has to equal the 180.
Right.
Okay, so let's simplify now. We have 2x plus 34 plus 104, right? Is 180. Okay, so what's 34 plus 104? 2x plus 168, right? Equals 180. So 2x equals what there? 12. Excuse me. What's this? 12, right? So now x equals 6. There you go. X equals 6. X equals 6 degrees.
Right.
Okay. All right, now for the y. Okay, so we have a y right here, right? There's our y. What can we say is equal to that y?
You could say 104, right?
Y.
Wait, I'm trying to see the Z method.
The z would be right here. This one. So it'll be that one and that one. So y would equal, well, let me draw it again.
It would be X, no, it would be 6 plus 17.
This one would equal this one.
So 20, y would equal 23, right?
Y would equal 23.
Because
Let's
the
write that out.
value of X is 6 plus 17.
Oh yeah, that's 23. Yeah, exactly. Yep. So y equals x plus 17, and we know that x is 6, right? 6 plus 17. There's your y, 23. Don't forget the degrees, right? 23
Yeah.
degrees. Okay.
Yeah.
All right, now for the z.
And for Z, that you're trying to solve Z. So here,
We know x, we know y.
so Z would be corresponding with X plus 17, right?
Say it again.
Huh?
Say it again.
Z plus 7 would be corresponding with X plus 17, right?
Yes. Yep. All right, let's write that. Z plus 7 equals x plus 17, right?
Right.
All right, now substitute the x in there. So z plus 7 equals 6 plus 17, which is 23. 23. So z plus 7 equals 23. So therefore z equals what? 16. I was thinking add up this one, and this one. We should get one. We should get the same answer though.
Oh, you subtracted 7 and 23. What did you add
23,
those?
23 minus 7.
Oh, I thought you would add. Oh, yeah.
Subtract 7 from both sides.
Yeah.
I was thinking if I was to add up the two, we know x is 6, so that was 2 times 6 is what? 2 times 6 is 12. 12 plus 10 is 20, 22 plus, what do we get for y? We got 23 for y. Does that make sense? Uh, 2x, so this will be your 2x plus 10. This will be your y. And then plus your z should equal 180. What do we get for z? Oh, that's what we're trying to solve for. What is this? 45 plus z equals 180. All right, that yields a different answer. Okay, but for the z pattern though, let's see here. For the z pattern, this has to be parallel to this. And same with the opposite way. This has to be parallel with this. So let me think about if we can use z pattern there. We gotta make sure if we can use z pattern. All right, so what did we say? We said that, which one was that? That was what we said that, no, I don't think we can use z pattern because there's no parallel lines. Yeah, we can't use z pattern. X is good. What did we do for, once we had x, what did we do? We completely solved the triangle on the right.
Yeah.
If we have x, oh, since these are isosceles, This is what we do. There's no parallel line, so we can't use Z-pattern. Let's redo, we got to redo, okay, so since we have X, let's come back here. Let's go back here. All right. Okay, so we have X at 6. So this is 23. This is 23. Does that make sense? 6 plus 17 is 23. 23 and 23 is 46. 46 and 104, that's not 180 though. X plus 17. Let's see if we did this right. 2 of those, 2x plus 34, 2x plus 34 plus 104 is 180. 2x 34 and 104 is 168. No, it's not. 138. That's where I messed up. This is 138. My bad. Yeah, that's where I messed up. Yeah, so I knew something was wrong. I messed up this line right here. Let's redo that because that doesn't make sense. All right, come back here. All right, so 2x 104 and 134 is 8, 3, 138. That's where we went wrong. Okay, so now 2x equals 180 minus 38 is 21. Is that right?
Yeah.
No, 42. X is 41. Oh, wait a second. Let me do this properly. 34 plus 104 is 138. That's right. 180 minus 138 is 42. Yeah, so this is 42. Okay, that makes more sense. Okay, this is 42, and therefore x is 21. X equals 21. Okay, that makes sense. Okay, since x is 21, okay, so now x is 21, so let's fill this in here.
So X is no longer 6.
No, x is 21. I added wrong, sorry.
Okay. That's fine.
Okay, 21 and what's 21 plus 17? 38. Yeah, that makes sense. This is 38 and this is 38. Okay, there's your 180.
21 plus 17 is 30. Okay.
Yep. Okay, so now on the triangle on the left-hand side, we're going to say this and this are the same because it's isosceles. So let's find z first. Z next. So 2x plus 10, 2x plus 10 equals this one right here, z plus 7. Z plus 7. So now we know x is 21. So 2 times 21 plus 10 equals z plus 7. Z plus 7. 21 times 2 is 42. 42 plus 10 is 52. So 52 equals z plus 7. Therefore, z is 45. Okay, so there's your z, 45. Okay, now we're going to find y. Okay, so now we're going to add up all three. Yeah, that makes sense. Okay, so we're going to add up this one. We're going to add up this one, plus the y has to equal 180, right?
Right.
So 2x plus 10, that's one of them, plus z plus 7, that's another one, plus y equals 180. Okay, so 2x plus 10, that's 52. 52 plus z is what? 45 plus 7 is 52. It's also 52. Plus y equals 180. So therefore, y equals what? This is 104. What's 180 minus 104 is 76. There you go.
All right.
So 76. Yeah, that makes more sense. Yep. All right. That's how you do that one. 12. All right. How many more we got? One couple more.
Oh,
13, 14, 15.
this one's pretty easy.
Okay. All right. Let me. Oh,
Last few.
did you copy down the red?
Yeah, I did.
Okay. I'm gonna erase it. Oh, this one you just say which one, right?
Let me draw these on my paper.
All right. Scroll up a little bit. I just want to see what they say there. Directions. State the postulate or theorem that can be used to prove the triangles are congruent. If they can't be proven congruent, write NE1 for not enough information. Okay. NEI. What's this one right here? HL. What does that mean? What does that mean? HL?
That one is for when there is a right angle involved.
Oh. Okay. All right. All right, for number 13. Okay, so we have angle, side. Okay, so there's your angle, there's your side, and there's your other angle. So this one is ASA. Second one. Okay, we have parallel lines, so we can use the Z pattern. This one is the same as this one. What do we have? We have anything else?
You have the tick right in the middle, right?
You mean this?
Oh yeah. The double one, no?
This just means that those lengths are the same.
What about the parallel on the other side?
Yeah, this means parallel. Yeah, that means parallel.
So nothing else then.
Okay, so let's see here. Okay, so the parallel tells us a couple things. The parallel tells us that okay, so since this is parallel, we could use Z pattern here. This angle is the same as this angle. Okay, so what else we have there? We have angles, side. What else do we have? We have anything else?
Would this be AAS?
AAS. What are the two angles?
Parallel?
Well, since these horizontal lines are parallel, that tells us that that is that. So that would be the first angle. Where would be the second angle?
The two vertical angles on the line.
Two vertical angles. Draw like where you mean where?
The semicircle on
this.
Yeah.
And would be equal to this.
Yeah.
That would be if they're parallel. If we extended this line and extended this line, that would be true. Well, in order for that to be true, these would have to be parallel.
Oh, are they not parallel though?
Not those ones. The horizontal ones are parallel, not the vertical ones.
I thought you could have more than two parallel lines.
You can, but it doesn't state that this is parallel to this.
Oh, so if it doesn't say, don't even.
Yeah, you can't assume it doesn't say.
Okay.
This one, I was thinking this one is we have the angle there. This is the same as this because of Z pattern. This is the common angle or common side between them. And then, yeah, this one is side, angle, side. Here's your side. Here's your first side, which is this. Then you have the angle, which is this. Then you have the common. Yeah, this one's SAS. Side, angle, side.
15.
15. Okay, so it should be obvious. Which one?
Huh?
Which one of the theorems? Which one of the proofs? Like which one of the which one of these?
Would it be ASA?
ASA, yeah, angle, side, angle. Yep, angle, side, angle. What's this one? 16.
16. That would, I think this one is already AAS.
AAS. Show me the AAS.
The angle on the left side and the S in the middle and the A on the other side as well.
Should draw it on the screen.
How do I draw?
Do you see on the very top view options?
View options. No.
Annotate. Do you see?
Oh,
annotate?
okay. Annotate. Okay.
No, yeah, annotate.
So the angle here.
Okay.
The S.
Well, okay. The S there. Where's the S though?
In the middle, no?
No. It'd have to be like number 14, where the side is common to both, or like 15, where this side is common to both.
Right.
So the only thing common to both would be this angle and this angle. Those would be equal.
Okay. So, and then what would the side be?
That one might be the single ticks mean those are the same length. The double ticks mean those are the same length. So that one would be, we have two sides, but we don't have the angle between. SSS, SAS, AAS. I think that one's not enough information. If we have two S's, the angle has to be between. See this one right here? Let me show you. See this one right here? SAS?
Yeah.
The A has to be in the middle, right? And then this one, the S has to be in the middle. This one looks like we have 60 for 16, we have side. If we had this angle right here, it would be SAS, but we don't have that. We have two S's. We just don't have the, we have two S's, we don't have the third S. We don't have the angle in the middle. We don't have a third S. I think this one's NEI and not enough information.
Okay.
Yeah, I think that was not enough information. 17. 17, we have, what do you think about 17?
I think 17 would be angle, side, angle.
Show me the angle, side, angle.
Because the angle here, oh crap. The angle here, the bisector, and the angle here.
Well, what's the one in the middle that you said?
The bisector.
So would that be A or would that be S?
S, no?
Yeah, it would be S. But how do you know the two angles on the sides equal each other?
Because the two lengths are equal to each other, no?
The two lengths are equal to each other, but that would mean this would equal this, and this would equal this.
Oh. So it'd be here, here, here.
Yeah.
It'd be like that?
Yeah. Wait a second. No, because remember these two double ticks are on the left side, and these single ticks are on the right side. So it's kind of like this. If we broke it into two triangles, this is isosceles, which would mean that, yeah, this angle and this angle will be the same. So this and these two would be the same. But that doesn't necessarily mean that these two are equal to each other. Well, those two are equal to each other. But what I'm trying to say is the first two are not necessarily equal to the second two.
Right.
That one, but the side in the middle is common to both. That's true. Angle, side, angle, side, angle, side. No, it's not that one. Angle, angle, side, angle, angle, side. I think this one's NEI too. Actually, you know what? I'm thinking 16. Let me change 16. I think this angle is the same as this angle. So this one would be side, angle, side, and then this one would be NEI. Not enough information.
So 16 would be angle side, side, angle side.
Yeah,
Okay.
yeah. This is why. This tick is the same as this tick, same length. I mean, this tick, double tick, is the same as this double tick.
Oh wait, I
It
think
has
he
to follow
had.
the same-
Wait. I think he had notes on this one except. You can check.
Side, angle, side.
Remember that page with like all of the triangles?
Yes, I think so.
Yeah, I'm gonna try to find that. Wasn't here. So wait.
Back in the yeah, somewhere here.
Not this one. Oh, it was the one below this. Probably no. So wait. Was it? I lost it.
Oh, see on the bottom there was the triangle classifications.
Triangle what?
See the one on the bottom, second from the bottom. Yeah, that one. That was the triangle classifications. Remember we did what was it, like acute and isosceles and all that.
Oh no, this is not.
It's just problems. It's just problems. Okay.
Yeah. I think it might be this one right here. Yeah.
Oh yeah, right there in the middle. Okay, look for SAS. Where's SAS?
SAS. Right here.
Okay, number five, number six. Yeah. Okay, so see number six, how the angle in between the two ticks has to be the same. So that's the same thing we had on the homework question.
Oh, and then the one that we did, number 16, would be AAS because it says it here.
Which one is that? AAS?
Yeah, the last, like number 16 on our paper.
But that's, or you're saying number 16 on our paper corresponds to number 14 here?
Yeah.
But see, on number 14 here, they're giving you their 90 degrees there. On the homework question, they don't give you that 90 degrees there.
Oh yeah, yeah.
Okay, look at number 7, NEI, right? Not enough information. Which one was that like? And then number 7 and number 8 are NEI. Go back to the homework. Which Which one are we on? We're on, which one? We're on
17.
17. Okay, so this will be angle, side. Okay, this one. Okay, well, look, if this is 90, this has to be 92. All right, because this is a straight line, 90 and 90 is 180. So you'll say 90 side, oh, my bad. You'll say angle, side, angle, angle, side, angle on this one. Angle, side, angle, ASA for 18.
Okay. So that should be all.
When does that due? Thursday?
Yeah.
Okay. Yeah, that's a few. That was a good homework, right? A few questions, a good few questions there.
Yeah, and then for chemistry, I'm not sure if there's not really a lot to go over.
All right, I'll try. I'll see what you do in the chemistry. Let me see, because it's not my strong suit.
All right. So the thing is with the chemistry, I don't think he posts the stuff like how this teacher does.
Oh, okay, okay, I see.
So I have to like look at my notebook and tell you like what's happening because I wrote notes about it.
You have homework tonight that's due tomorrow, or tomorrow you have homework, or what?
Huh?
You have any chemistry homework tonight that's due tomorrow?
No, I don't have homework. It's just
I got you.
It's just notes. I'm gonna tell you. It's about okay, so it's about Louis de Broglie's like development of the quantum model of an atom.
Okay.
And it just talks about like the waves, the electrons in the waves and stuff, and the Heisenberg uncertainty. You know that stuff?
Not off the top of my head, but if I looked at it a couple of times, I think I'd figure it out.
Yeah, it's just notes though. It's nothing. It's nothing.
Okay.
No work yet for it.
Oh, okay, so it's just understanding the concept, basically.
Yeah.
Okay. So just reread the notes a couple of times tonight, and then maybe again tomorrow.
Yeah. All right. Thank you for the help.
You're good today? You're all right today then?
Thank you.
All right. You said you have math every day or every other day?
Every other day.